Hi, Pro Relay Techs. I'm Dennis Moon with Energy System Solutions. I'm going to do a little presentation on a GE IAC overcurrent relay, and specifically we're just going to address the connecting plug and the shorting block that helps prevent open-circuited CTs. So sit back and relax and just watch this short, simplified little presentation. I think you'll enjoy it. Thanks. Okay, Pro Relay Techs, here's our GE induction disk time overcurrent relay with the connecting plug inserted. We also have 1 amp across these two wires right here going into studs 5 and 6 on the back of the relay. So during this video, if at any time the current circuit is interrupted by being open circuited, our test set's going to squeal on us and whine and tell us it doesn't like that. Right, so first of all, let's take a look at our connecting plug. So I'm going to go ahead and pull this guy out. There's 10 connectors. They're solid, wrapped around the plug itself. So that means it doesn't matter how you insert it. There's no top, there's no bottom. As you can see, solid silver-coated copper that is inserted into the relay, and when that happens, then we know that there's spring-loaded fingers in the bottom of the relay can and the bottom of the relay, and when we insert this connecting plug, then we make contact with those spring-loaded fingers on the bottom of the relay and the bottom of the relay can. Now notice when I took this connecting plug out, with 1 amp applied, nothing happened, and nothing should have happened. So I'm going to go ahead and insert him back in again. Now you'll notice the relay just slightly lifted up there. The current's now going through the relay, studs 5 and 6, through the connecting fingers on the bottom of the relay can, through the connecting plug, and through 5 and 6 on the bottom of the relay. Right, let's pull him out. Nothing's going to happen. We don't want anything to happen. Let's set him aside and let's pull our relay out and take a quick look at the fingers on our relay. So we'll get him out, set him to the side over here. Okay. So this exposes the fingers in the bottom of the relay can. Here's stud 5, here's stud 6. I'm going to tip this forward just a little bit so that you can see that we have right here dimples that are holding the springs from getting away. So that dimple presses down into the center of the spring. Okay. When we pull the connecting plug out, then this finger is forced upwards. This finger is forced upwards. And note that there's a shorting block right there. Then that shorts the current when we pull the connecting plug across 5 and out 6 and keeps the secondary of the CT from being open circuited. Now, to prove this, we're going to go ahead and push down on stud 5 and separate him away from the shorting block. Remember, there's 1 amp applied here, and we should get our test set to squeal. Here we go. Yep. Didn't like that. Okay, so that proves then that the current circuit in 5 through the shorting block, back out 6. Again, when we put the connecting plug in, it presses down on these springs and makes contact with the connecting plug rather than the shorting block and up through the relay. So the same springs that we see here are mirrored on the relay. I'll show you those. So I'm going to set this can aside for just a moment. And I'm going to bring our relay in and show you the bottom of him. And there's our spring-loaded fingers here. 1, 2, and 3 are the trip circuits for the induction disc and instantaneous. 4 is the tester's port, and there's 5 and 6. And you can even see, if you look closely here, the scrapings on the silver where our connecting plug's been inserted and taken out multiple times. Remember, again, those are spring-loaded, and I'll just go ahead and push on this guy so that you can see. Can you see that movement there? Those guys are spring-loaded, so that there's always positive pressure on the connecting plug and positive pressure on the shorting block when we remove the connecting plug when the relay's in service. So there's a good explanation of how GE prevents an open circuit from the CT using the spring-loaded fingers and a shorting block. Thanks for watching. Okay, Pro Relay Techs. This is just a little 30-second clip for those of you that wanted to look a little deeper into how this shorting mechanism works on switch 8. So I just want to show you, there's the shorting bar right here. So you can see then that it's U-shaped, and very simply, when switch 8 is open all the way, it presses down against that shorting bar and shorts out 8 to 9. Okay. Then when I close the switch, it makes with the relay on stud 8 and disconnects from the shorting bar, but that's fine because the relay's in and the current flows now through the relay coil in 9 and comes out 8 rather than across the shorting bar. So that's just a little extra to show you how that shorting bar works and what it looks like. Thanks for watching.